Hi, and welcome back. This is probably the most important video of the series, as we will talk about combinations. We already know that permutations are ordered arrangements of objects. On the other hand, when we make a combination of objects, order does not matter. So let's see an example. Here we have a list of amino acids, and let's say that we have the amino acids A, N, K, and L in our hands. Now let's calculate manually the total amount of combinations of those amino acids, taken 3 at a time. So the first combination would be A, N, and K. Second combination would be A, N, and L. I remind you that order does not matter. A third combination would be A, K, and L. And our final combination is N, K, and L. So the amount of combinations of those 4 amino acids taken 3 at a time is equal to 4. Now let's calculate their permutations. I remind you from the previous video that the general formula for the permutations of n objects taken k at a time equals n factorial divided by n minus k factorial. Okay, so the permutations of those 4 amino acids taken 3 at a time equals 4 factorial divided by 1 factorial, and that is equal to 1 multiplied by 2 multiplied by 3 multiplied by 4 equals 24 permutations in total. Notice that the amount of permutations is 6 times as big as the amount of combinations of those amino acids. And in fact, 6 is equal to 3 factorial. And 3 is the amount of amino acids that we use in each of our combinations. Okay, so in general, we can deduce that the amount of permutations of objects is k factorial times as big as their combinations. Okay, so we apply this to our new formula, and we see that the amount of combinations of n objects taken k at a time is equal to their permutations divided by k factorial, and that is equal to n factorial divided by k factorial multiplied by n minus k factorial. Okay, the most usual way to describe a combination is using the symbol, and we read it as n over k. So this is by far the most important formula in basic combinatorics, and from now on we will be able to solve a vast amount of problems that would otherwise seem impossible. In order to understand better the difference between permutations and combinations, we see that in each of our 4 combinations there corresponds 6 permutations. We take, for example, our first combination, which is A, N, and K. Since this is a combination, the order of the amino acids does not matter, but to its corresponding permutations, the order does matter, and we have the following permutations: A, N, K, A, K, N, N, A, K, N, K, A, K, A, N, and finally K, N, A. Okay, so all these permutations correspond to this one and only combination. And since we have 4 combinations in total, we multiply this amount by 4, and we get 6 multiplied by 4 which is equal to 24 permutations in total. So here is an example that may not be of biological nature, but it will surely help us understand more the concept of combinations. We have 10 points in the plane, so that no 3 of them are collinear, and the question is, how many triangles can we construct using these points as vertices? So we combine these points in order to construct triangles. The order that we pick them does not matter. And if we didn't know the formula of the combinations, we would have to draw these triangles by hand. This would be a time waste, but now that we know the formula, we know that we have to combine those 10 points, 3 at a time, because a triangle has 3 vertices, and that is equal to 10 factorial divided by 7 factorial multiplied by 3 factorial. That is equal to 8 multiplied by 9 multiplied by 10 divided by 2 multiplied by 3. That is equal to 4 multiplied by 3 multiplied by 10. And now we know that we can construct 120 triangles using these points in the plane as vertices. So the next question is, how many pentapeptides are there so that they contain 2 leucines as amino acids and so that every other amino acid is arginine? Okay, so we take, for example, the case where the second and the third position are filled with leucine and arginine fills every other position. Now in this example, we must be careful and not take permutations like we did in the previous videos, as if we did, then this pentapeptide would be counted twice. The order that we place the leucines does not matter. If we did take permutations, then this pentapeptide would be considered different from this pentapeptide. Okay, but the order that we place the leucines does not matter, so we don't want that. All we have to do is combine those 5 positions of amino acids. We take 2 at a time, and that is equal to 5 factorial divided by 3 factorial multiplied by 2 factorial. That equals 4 multiplied by 5 divided by 2. So we have 10 pentapeptides in total that satisfy our condition. Okay, so to sum up, today we learned a very important formula. N over K equals n factorial divided by k factorial multiplied by n minus k factorial. And that's it for today, and in the next video we will make a small revision and we'll see some more examples. Bye bye.